Welcome, ladies and gentlemen. This is going to be our video for domain and range of continuous data. So our objective for today is mathematicians will determine the domain, which are our x values, and range, which is our y values, of continuous data. So continuous data from last class, we said it was something that's connected on a graph and can be measured. Connected and measured. Our essential question, how do we use inequalities to represent the domain and range of continuous data? So instead of just listing out, we're going to have to use inequalities today. So our inequalities less than, greater than, less than or equal to, greater than or equal to. Then we go ahead and complete our attendance question. So our first one says the average person gets their hair cut 5 times a year. The average the average price is $35 for each visit. List the domain, haircuts, and range price over the course of 1 year. So our domain is our number of haircuts. So we list out the possible number of haircuts we could get. Well, we could start off the year with 0 haircuts, and then as we go along, we get 1. A little bit further along in the year, 2. A little bit further, 3, 4, up to 5. Because the average person gets 5 haircuts. And then the range is going to be how much each of those haircuts cost. It's going to be the price to get those haircuts. So if we have 0 haircuts, we have spent $0. If we get 1 haircut, we have spent now $35 because the average price is $35. 2 haircuts would now be the price of 2, so $70. 3 haircuts, $105. 4 haircuts, $140. And 5 haircuts, $175. So each time we just increased by 35 to get our next range value. Now we want to determine the domain and range of the relation shown on the graph. So looking at this, we've got these points on the graph. It is discrete because they are disconnected. So we're going to list out our domain and our range. In order to do that, I'm going to take each of these points and move them down to the x-axis because domain is x values. So -5. Then C and D actually both give us -2. Since C and D have the same x value, does this represent a function? No, it is not a function because C and D both went to -2. It does not pass the vertical line test right here. Okay. So now, continuing on with our domain, that was just a quick review. F goes to 2. E has an x value of 3. And A has an x value of 5. That's now all of our x values. And for our range, we want to list out the y values. So we're going to move all of these points over to the y-axis so that we know exactly what their y value is. So -6, -4, -2, 3, 5, and 6. So notice when we did the range, I started from the lowest point on the graph and moved up. Because I did that, are my range values written lowest to highest? Yes, they are. So anytime we have a graph, if you guys want to make sure you write it in least to greatest, all you have to do is start from the left and move to the right, and then start from the bottom and move up. Good. So today's lesson, we're going to be continuing with domain and range, continuous data, continuing. And we want to do a quick review of whether these graphs represent continuous data or discrete data. So the first one, in order to decide if it's going to be continuous or discrete, we have to determine if it is connected or if it is disconnected. And what that means is there a line or is there not a line? So on the first one, is there a line? So it is continuous. Okay, does it have to have an arrow? No, it does not have to have an arrow. Can it have one? Sure, as long as there's a line, it is continuous. And then the last graph, if you notice, it's just a bunch of dots on the graph, and they are not connected. There is no line, so it is discrete. Okay, so from a graph, is there a line or is there not a line? From word problems, it's a little bit harder. So we have to decide for continuous, is it measured or is it something that we count, discrete? So continuous, measured, discrete, counted. The height of an airplane, is that something that we measure or something that we count? Well, height is something that we measure. So the height of an airplane is something that's measured. So this is continuous. Cost of sodas sold for 50 cents each. Sodas. Do we count sodas or do we measure sodas? We count them, so that is discrete. Touchdowns scored. Do we count touchdowns scored or do we measure the number of touchdowns scored? That's also something we count. We count scores, so that is also discrete. And then temperature outside, is that something that we measure? Temperature is something we measure, so that would be continuous. Okay. If you have any questions about continuous versus discrete, make sure you reach out to me in Canvas so I can try to give you some more examples and maybe try to figure out a way that will make sense for you so you know when it's discrete and when it's continuous.